Let's start on this. Are you able to hear me, right?
Yes, yes.
Okay. So let's see. The last topic what we discussed yesterday was the sampling. Yeah. So what we do with sampling? Okay, let's suppose in a table we have some millions of data, and for my data profiling purpose to see the sample data, I need only 100 records. Okay, so we can restrict the output to 100 records with the help of the keyword sample. Okay, this sample should be a prefix for the entire query with a number or a percentage as a parameter, so that it will restrict the number of records to be shown as output. Okay. So if we have some hundreds of records, and if I want only 10 records, I can give select star from employee sample 10. So it will give you 10 records. Okay. Or if I wanted to get 50% of the records, then I can give 0.5. It represents the percentage of the rows. You can do multiple samplings also to make the data more random, so that it would be helpful to understand the full patterns of the data. So it is all required for the data profiling to see how the data behaving or the data behavior, okay, with more samples. Return 6 rows from 3 different samples, so no duplicate rows are returned. It will make the sampling more random, so that it will be helpful to see the full or almost, okay, almost the all trends of data in the table. Okay. So there are some variants of samples. We can have conditional test for samplings. Okay. So where we can use, if product ID is less than or equal to 10, then I want 10% of rows with this condition, and for else I need 50% of the data. Okay, like this you can use the case when conditional sampling also, so that we will have the sampling for the required data. We can use the conditions also. So select star from sales table is our normal query, but within this I want product ID is less than or equal to 10 records are of 10% out of the total count, and the remaining records are of 50% of the count in the table. So like that I can use conditional test in the sampling of the data. Okay, so here we have the rank function. Okay. Rank gives a ranking for a certain data, okay, a certain column. So if you see the example, select product ID, sales date, amount, and I want ranking on the amount column. Okay, so whenever we see the Olap function, okay, so today we are going to see the Olap functions. Okay, these are the advanced TERADATA functions which are used for analytical purpose. Okay, so out of the Olap functions, the rank is the first function what we discuss in any of the session. So that rank will give a minimum idea of how to use the Olap functions, and then we'll go for the remaining statistical and analytical functions. Okay, the first function of analytics is the rank, where we can find out the rank of a certain entity. Okay, so here in this example, we are trying to find out the rank on the amount field. Okay, as best to worst. That means this is aliasing of this rank. Okay, here we will say this is a derived function, because the rank of amount is not existing in the table, but we are trying to derive with a calculation and with a function called rank. The rank on amount gives the rank on the amount column values, okay, and default it is from high value to low value, that is descending order. By default, this rank function arranges the data based on the amount in a descending order, and then it will start ranking. The highest amount would be as 1, the lowest, the second lowest will be of second, and so on. And whenever there is a collision of the data values, a rank will be shared. The same rank will be shared for the same values, and the next value the next rank will be derived with the formula like the rank plus the number of items shared the same rank. Okay, so here 6 plus the number of entities sharing the same rank is 2, so 6 plus 2, so the next rank would be 8. Okay, so that is how the next rank would be derived. Okay, so when we have a 6th rank is shared by 2 people, the next rank given to the next item would be the rank plus the number of items shared, that is 8 in this example. Okay, so these are the characteristics of rank. Whenever you apply a rank function, the analytical function rank on a particular field, okay, internally what it does, it will do a descending order of the data. This one. So, okay. First it will sort the data based on the amount in descending order, and then it will start giving ranks from highest to lowest, starting from 1 to the rest of the numbers. And whenever there is a value with a share between 2 different rows, the rank will also be shared, and the next rank is derived with the current rank plus the number of entities sharing the same rank. Okay, so that the rank will be given in such a way. Okay, so these are the characteristics of a rank function. In case if you want the data should be ordered in the reverse order, it means in ascending order, okay, we can use the keyword ASC after amount field. Okay, so that the data will be arranged first and then the ranking will be given. So in that scenario, the ranking will be given 1 to the lowest salary, 2 to the second lowest salary. Okay, so if we need the ranking in the reverse order, we have to use the ascending keyword after the amount field here within the parentheses. Okay, so let us try one simple example with the rank. Select star from employee. Okay, where we are having the salary column where we want to rank, let's suppose. So these are the salaries. I just wanted to rank them based on the employee salaries. So how I can make it? Select employee number, e-name, comma salary, and I wanted rank on salary. So rank is the function. Okay, I wanted to sort the data based on salary in descending order and wanted to assign ranks to them. Rank is extend. See, I didn't mention any sorting order, but still the data is ordered based on salary and the two in descending order, and it has given rank, okay, where 1 is for the highest salary and so on. And wherever the salary is found equal, it is sharing the same rank, and the next rank is given with plus those many number of ranks, those many number of rows which are sharing the same rank. Okay, so 5 is also shared 2 times, so the next rank is 7. 7 is also shared 2 times, the next rank is 9. Okay, like this. rank will do the sorting of the data and assign the rank based on the amounts. In case if I want the lowest salary to be given, the rank ASC. I can use the keyword ASC to mention the ascending order of the data. The lowest salary will get the first rank. The highest salary will get the least rank. Okay, in case if you have a requirement to reverse the rankings, you can use that. And now, if my requirement is not to display ranks for all the data, but I wanted to see only top 3 salaries. Okay. So let's suppose this is my purpose of using this rank to see only the 3 top salaried employees. Okay, so this is my analytics, what I wanted to perform, okay, to see who are the topmost earning employees in my organization. Then I can go for filtering out the output of the Olap result. Okay, so whenever we have to filter out the result of a Olap function, we have to use the clause called qualify. Okay. So whatever output we are getting for this SQL, that can be filtered out with the qualify clause. The qualify rank of salary is less than or equal to 3. So I would get top 3 salaried employees only. See? So these are the 4 employees who are getting top 3 salaries. Like this, you can qualify a certain number of ranks to show as a answer set. If I want least 3 salaried employees, then I have to reverse the order and then qualify the top 3. I would get least 3 salaries and least 3 employees who are getting least 3 salaries. Like this, rank function can be used to sort the data, to rank the data, and you can use the qualify clause to filter out the output of the Olap function, any of the Olap functions. Okay. So this is all about the ranking, where you can qualify it. Okay. You can observe in qualify I have used the alias name. Okay. That is the best practice. Wherever you want the qualify to be used, either we can apply the function on the same column again, or you may use the alias of the function. Here in this example, if you see, select product ID, sales date, amount, rank on the amount as best to worst. Okay, he has aliased it to display in the answer set, but here he didn't use the alias name for the qualify. Okay, what he did, instead of the aliasing, he has applied the function again on the amount to get the top 5 amounts. Okay, so this is also a way to get this, but it is not preferred, because if you observe, we are applying the same function 2 times in the query, and as it is a Olap function, it may take more resources. Okay, applying 2 functions and the calculation of the same value 2 times in the same query is not preferred. So it is best practice to use the alias name in the qualify clause. Okay. Okay. And the next function would be cumulative sum, CSUM. Okay, so before going, let me see if you have any questions on the Olap function rank. Very clear about rank?
Yes, clear.
What we do and how we do?
Yes.
Mijan? Hari? Hari, are you able to hear me?
Yes, yes, I'm able to hear.
Okay. So any questions in ranking?
No
Are you
question.
clear how it goes?
Yeah, it's a straightforward.
Yeah, it is a straightforward rank function. Yeah, I will show you the ANSI standard of rank also after some time. Then you will get a bit difficulty in it. But now the rank function is almost simplified with the simple function rank on the data. It is very much straightforward. Yeah, and the qualify is also very much straightforward where we use a where clause. In similar way, we use qualify to filter out the ranks. So let's go ahead for the next function, cumulative sum. So it is almost similar where we use CSUM function to calculate the cumulative sum. Okay, so before applying function is not a big thing because we know the syntaxes, how to make it. Okay, it is only the thing we have to know what are the parameters to pass and what it does. Okay, and basically for cumulative sum, we may have to see what this cumulative sum function does in statistical manner. Okay, the concept of the statistical functionality of cumulative sum. Okay, so to understand this, let us consider this example: product ID, sales date, amount, and this is the derived function CSUM on amount with the order of sales date. Okay, so if you observe, CSUM is accepting two parameters here. First one is called amount, the second one is sales date. Okay, so the first parameter is on which we need to calculate the cumulative sum, and the second parameter is, okay, in what order the data should be arranged first to calculate the cumulative sum. Okay, so first the data will be sorted based on sales date. See the sales date sorting order, and then it will start calculating the cumulative sum on the amount column. This is the amount column. Okay, so let us see what is the CSUM on the amount column here. For the first row, it is 6,000. For the second row, it is 13,000 plus the 6,000, means 19,000. Okay. And for the third row, including this amount, we need to calculate all the previous amounts also. So 4 plus 13, 17 plus 6, 20. Okay, like this, for every row, the cumulative sum can be calculated as the sum of all the rows which are preceding to that. Okay. So at any point, if you see for the last record, it is nothing but sum of all the amounts in the data. Okay. So this is called the cumulative sum. For any particular row, the cumulative sum is nothing but the sum of all the rows which are preceding to it. Okay. But before this, the data should be ordered on a particular field, which is mentioned as second parameter in the cumulative sum. Okay, so for all the Olap function, the common characteristic is the order of the data. Okay, so for some functions, you may have to mention the order explicitly with the second parameter, and for some functions, the column on which you want to calculating is itself gives the order of the data. Okay, in rank, we have seen the column itself would be arranged in the order based on the value in that particular column. In CSUM, there is a second parameter. Actually, it is not only the second parameter, the rest of all parameters. Okay, only the first parameter is on which we need to calculate CSUM. If we give more than two columns in CSUM, okay, all the rest of the columns are considered for the order by clause. Okay, order by clause is nothing but sorting the data based on the values of the columns which are given as the rest of the parameters except the first parameter. Okay. So if I give two dates, the sales date comma product ID, let's suppose I have given two columns for the sorting order, sales date comma product ID here itself. Okay, so the data will be sorted based on sales date first, and then if sales date is collision, okay, then it will arrange data within the prod IDs, and then it will calculate the cumulative sum on the amount. Okay, so for all the Olap function, the order of the data is also important, and it will be derived as the parameters within the function. Okay, so here the syntax is CSUM. The first parameter is on which we need to calculate the cumulative sum, and the second parameter is based on which the data has to be sorted first. Okay. And now CSUM with the help of a group by. Okay, that means in CSUM, that means in cumulative sum, for any row, it will try to add all the records preceding to that particular row. Okay, but if you want to do the CSUM in a particular group only, okay, not to all the records, but if the records are belonging to a particular group or a partition, then only I have to do the CSUM. Otherwise, I have to reset it from the first record onwards. If that is my requirement, then what I can do, along with the CSUM function, I can go by group by clause. Okay, I can use a group by clause with the Olap function. Okay, here the meaning of group by would be a bit different when we are using with Olap functions. Okay, what it does, this calculation will be performed to the groups of the sales date, the groups of the field which is mentioned in group by clause. Okay, so let's see this example. Here, what is the order? Okay, CSUM of amount, comma, sales date, comma, product ID. Okay, so first the data will be arranged based on what data? Okay, except the first parameter, it will consider all the remaining parameters as the sorting ordered values. Okay, so it will sort the data based on sales date, comma, product ID, and then it will try to calculate cumulative sum. Okay, so let's see the example. 6,000 for the first record, the running total is also 6,000. Okay, for the second record, 13,000 plus 6,000 is 19,000. Okay, before doing it, it will check if the group is same for these records or not. Okay, that means sales date. If sales date is same for these two records or not. The sales date of two records is same, so it can do the cumulative sum. Okay. And the next record is 4,000. Okay, if it is a normal cumulative sum, it should have added this 4,000 to these previous two records, so it would become 23,000 something. Right? But here, if you see, the group is different. I think the sales date is changing here for the third record. It is not the same group of the other two records. Okay, so it cannot add this particular amount to the previous amounts which are preceding to it, because we have given a group by clause of sales date. So whenever the records are of same sales date, then only it has to add the amount. Okay, so here it cannot add it, so it will reset the CSUM for the first record. Okay, for this group, this is the first record, so the cumulative sum is 4,000 plus 0, 4,000, because there is no other record preceding with the same group of sales date. Okay. And then the fourth record is coming under this group itself. Okay, 1 to 2004 and 1 to 2004. The group is same. So now the cumulative sum is 14,000 plus 4,000, that is 18,000. Okay, and for this record 1-3-2004, so it is 3,000, and this is not equivalent to 1 to 2004, so it has to reset it. And the other record is having the same group, so it will accumulate it. Okay, like this. The group by could also cause the CSUM to be calculated within the same groups. Okay, if we don't give a group, the cumulative sum will calculate all the records which are preceding to the current record. But when we are doing a group by, it will do an extra check to identify if all these records are coming under same group or the same partition or not. Okay, so that is the purpose of having CSUM with a group by functionality. Okay. Now let's see the CSUM with the ANSI syntax. Okay, nowadays we are not using this, but which are with the legacy code, okay, which were already written. If sometime if you have to, I mean, if you happen to see such type of code, okay, you should not get confused. So we are just giving an introduction how it was written earlier when we don't have a Olap function, a dedicated Olap function derived for this. Okay. So when we were not having a function called CSUM, okay, we were having a function sum itself, the normal aggregate function. Okay, we used to use the sum function itself on the amounts, and we have to use these keywords over, and then we have to mention order by clause within the brackets of over, okay, based on which the data should be sorted, and then we have to mention the keyword rows unbounded preceding. That means for the current row, unboundedly all preceding rows should be added. Okay, so that is the meaning of rows unbounded preceding. Okay, from sales to. Then to calculate the cumulative sum, we use it to write code like this. Select product ID, sales date, amount, sum on the amount, the normal aggregate function. But to make it as Olap, we have to use a clause called over, and within the over, we have to mention based on which the data should be sorted, and then if it is a cumulative sum, rows unbounded preceding from sales to. And in case if we need to mention the group by clause also, that means if only these two are same, then only to do the cumulative sum we have to use a partition by clause. Okay. Partition by sales date, order by sales date, and then rows unbounded preceding. Okay, that is what we used to write the code to derive the cumulative sums based on groups. Okay, and this is the ANSI syntax. Okay, and for rank also the same. Get rank on amount over order by sales date. Okay, that should not contain rows unbounded preceding. Just order by clause. Let's try the rank function here. Then ANSI stand. Just for information, nowadays we are not using it. Select employee number, email, cell, rank over partition by let's suppose anything, order by cell as rank of cell. See, I have mentioned partition by employee number. That means it is considering each employee number as a partition, and for this partition it is the first rank. For this partition it is first rank. Okay, let's suppose if we have a gender column. Okay, within the gender I wanted to view the ranks. We have to display gender column also just to see that. See, now First, it is trying to partition the data based on the genders, and within the partitions, it is trying to give you ranks. So in female, the 5 ranks, in male, 3 ranks. Okay. If we don't want the partition, we need a simple ranking. Okay. It is normal ranking based on salaries, and here if you observe, the default ranking is different. Just a moment. Hello. Okay. So you can use the ANSI syntax of the ranking with some more keywords, but it will also perform the same way with little difference. Okay. In our rank function, the default is descending order. Okay. But here, if you observe, the default order is ascending order. Okay. To convert into descending, we have to use descending keyword after the order by clause. Okay. This is a slight change between the normal and the Olap functionality. Okay. So the default order in the normal rank function is descending, and in ANSI standard rank function is ascending. So if you want in a reverse order of the method what we are using, we have to use the keywords ASC or DESC to alter the orders. And in this particular rank function, okay, which is the now new standard of rank function, the Olap function, if you want to make the ranks within the groups, you can simply use the group by function. Group by gender on ranks. It will group the data based on the gender and then provide the rank. See? Within female, the ranking; within male, is the rank. The same functionality you can derive in both the ways. This is the updated one. This is with ANSI standard. That is partition. Both are same, and qualify can be used with both of the methods. If I wanted to see only top salaries within male and female, this is the query in both the methods. Top salaries in female, top salaries. It is in reverse order. See, both the answers it's the same. Only the method of writing SQLs is different. So there is the ANSI syntax. There is the now updated function of rank. So CSUM also can be used with the over clause, over order by sales date, and here if this is the construct, the default order is descending, Okay, and rows unbounded preceding is to mention to go unboundedly preceding rows to calculate the cumulative sum. Okay, and then you can use a group by with the help of partition. Okay, how we use group by with the normal function. If this is the ANSI syntax, we have to use a partition by clause. Okay. And in case, okay, if we have a requirement to add only the just before two records, okay, to calculate the cumulative sum, we can mention rows to preceding. Okay, earlier we used to mention rows unboundedly preceding. That means there is no boundaries to go beyond to add. Okay, it can go up to the first record and add the cumulative sums. Okay, but here in case if we want to make the addition of only two rows at a time, okay, then we can go for rows to preceding. Okay, so see the example: 1,50,000 for the first record, and for the second record 1 lakh plus 150, 2,50,000, and then third record 2,50,000 plus 65,000. That means for the current record it is going for the two records only and is adding it. And if you consider the fourth record, you will clearly observe this is the sum of these three records. Okay, that is 2,25,000. Okay, because we are restricting only two rows just before this. We are not saying it is unboundedly preceding. It has to bounded to two rows only to calculate the cumulative sum. Okay, so this type of cumulative sum is called as moving sum. Okay, in cumulative sum, it is unboundedly preceding. In case if we wanted to make the boundaries while calculation of the sum, that particular functionality is called moving sum. Okay, you can mention it as two records or one record or three records, five records, so that for any particular record it will go those many number of records only and calculates the sum. Okay, so that is called a moving sum. Okay, so for calculation of moving sum also, now we have a function called msum. Okay, when we used to have only ANSI syntax, this is the only function available, and within this order by clause itself, okay, within the over clause itself, we need to mention all these parameters. Okay, what we want actually. Okay, if we want a cumulative sum, rows unbounded preceding. If we want a moving sum, rows to preceding, and order by clause we can use, and partition by clause we can use for the groups, the data. Everything we have to manage within this over function only. Okay, but now we have new standard functions coming up with msum, which is very much simple to use to pass the parameters. Okay, so in moving sum, the parameters are like this. The first parameter is on which we need to calculate the moving sum. The second parameter is, okay, how many rows we have to consider to make this moving sum, and the rest all the parameters. Okay, we can have n parameters, but all these parameters will be considered for the ordering of the data. Okay, first it will sort the data before calculation based on the order by clause columns which are mentioned here, and then it will start calculating the sum, and if it is a moving sum it will go only two rows up. Okay. In msum, the two includes the current record also. Okay. In ANSI standard, it is not including the current row, go for two more rows precedingly, but in moving sum function, if we give 2, it includes the current record also. Okay, so let us see the example. So first the data is sorted based on the sales date. Okay, so based on sales date the data is sorted. and then amount column is this. So it is calculating the moving sum for this current record and the just before record. There is no just before record for this, so it is 13,000 only. For the second record, 6,000 plus 13,000, 19,000. For 14,000, it has to go and calculate at a time 2 rows only, including the current row. So 14,000 plus 6,000. Okay, it can add only these 2 rows. It includes the current row also. So that moving sum is 20,000. Okay. And for this current record, 4,000 plus the second record would be 14,000. So it is 18,000. Okay, so here we are restricting the boundaries to only 2 rows at a time to be added. So this is called the moving sum. Okay. Any questions so far? In the ANSI standard, how to use? Okay, so I'm moving ahead. How we use group by clause with the CSUM? In a similar way, you can use the group by clause. Okay, while calculation of moving sum, it will see just before adding to the record. Okay, it have one more validation to see if this record also would come under the same group or not. If it comes in the same group, then it will use moving sum. Otherwise, it will reset the value. Okay, here for 6,000, 6,000, 13,000 it is coming under same group and moving sum of 2 records. So 16 plus 3, 19,000. 6 plus 3, 6 plus 13, 19,000. And for the third record it is 4,000 and it is coming under different group. Okay? Otherwise it would have been added 4,000 plus 13, 17,000. But as the groups are different based on the sales date, as we have used the group by clause on sales date, it cannot add to the other group of records. So it has to reset the moving sum to 4,000. Okay? So group by resets the calculation by sales dates. If the sales date is different, it cannot add the sum. It has to reset it, and till the rows are same group, it will try to add them. Okay? If you have any such requirement, you can go for using moving sum. Similarly, we have the other functionality called moving average. Okay, so moving average is a function which takes 3 parameters. The first one is on which we need to find the moving average and how many rows it has to consider at a time to calculate the average, and the third parameter onwards is the order of the data. So how to sort the data before calculation of moving average. The sales date, you will use the for sorting purpose, and then it will start with calculation of moving average on the amount. For 6,000 it is 6,000. For the second record, 13,000 plus 6,000 by 2, it is 9,500. For the third record, yeah, sum of these 3 records by 3, it is this much. And for the fourth record, the sum of the 3 records only, because we made the boundary with the moving average of 3. Okay, so at a time it can add only 3 records, and by 3 it is 10,333.33. Okay, like this, it will calculate the moving average of at a time 3 records, including the current record, by sales date order. Okay. And we can use group by with this moving average also, okay, to make the average to be calculated only to the groups. If the groups are changed, then the average will be reset. Okay. For first these two, the average is 9,500. For the third record, it cannot calculate the moving average with the just before records because the groups are different. So it has reset the moving average. For the second record, it is 14 plus 4 by 2, 9,000. So the group by is also common for all these Olap functions where it groups the data, and when the groups are different, you cannot make the calculation happen. Yeah. And this last Olap function is on moving difference. Okay. So it is also having the same functionality. Okay. Moving difference, on what column we need to calculate moving difference. Okay. And which numbered column we have to consider to subtract this, and what is the order of the data. Okay. See the example. So 13,000. Is there any second record for this to subtract? Nothing. So it is not applicable. For this also we don't have any second record to be subtracted from. Right? We have only one before, but we have mentioned two. That means it has to check second record from which it has to be substituted. There is nothing. For 14,000, what is the second record preceding to it? 13,000. So 14,000 minus 13,000 is 12,000. For the fourth record, it is 4,000 minus 6,000. It is minus 2,000. Okay. So moving difference is for the current record, okay, how many preceding row we need to consider for the subtraction and provide the moving difference. Okay. We can use group by clause also along with moving difference, where if the group is same, it will subtract, otherwise it will reset that. Okay. So these are the some important Olap functions what we use. The mainly used is the rank function and the CSUM function. The moving sum, moving average, or some more advanced calculations in terms. Okay, if they want the statistical calculations on the data to derive some analysis or to take some decisions, they may go for the moving difference, moving average, and moving sums. Okay, but majorly we go for the ranks and cumulative sum. Then if we understand the syntax, it is almost same for moving sum, moving average, and moving difference. Yeah, this is all about the TERADATA advanced Olap functionality. Okay, tomorrow we'll see the temp tables in TERADATA. Okay, we have three types of temp tables and three types of spaces in TERADATA. So we'll see what all tables use what type of space, okay, so that we can use the corresponding tables for, okay, based on the purpose. Okay, so derived table is having some purpose, global, volatile, the tables are having some purpose. We'll find out what is the purpose of these tables. Okay, if we create these tables, what space will be used, so to analyze if this space is reasonable to do this for functionality or not, and then go for using it. Okay, so this is the tomorrow's topic, where we'll try to find out different types of tables and spaces. So if you have any questions in this lab functions, we can discuss on this. Otherwise, we'll meet tomorrow and continue this topic, spaces and tables.
Hello,
Yeah.
Manohar.
Yes.
Can you send me the study materials of this?
Okay. You didn't get this?
I got only when we are in what is called structure of TERADATA.
Okay. Okay. I will see. I mean, what all was sent to you, and I will.
I think I got 6 chapters from the beginning.
Sure. I will send you the remainings.
Okay. Thank
Okay.
you.
Fine then. So we'll meet tomorrow
Mhm.
at the same time. Thank you.
Also, keep in mind from next week if you can move from
That
study
I'm
to
trying it for Mizan. I cannot promise it because I have some other things to cover it up. I will try to make it, but if that won't be solved, then we have to be for one more week.
Okay. Okay.
Okay.
Do your best.
Yeah, sure. I will do
Okay.
that. Yeah, I'm trying for that,
Okay.
but if it works out, I can make it. Otherwise, we may have to continue for this.
Okay.
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 Yeah. Thank you.
Thank you. Bye.